when you're ready. Great. Okay, so yeah, thanks everyone for joining today. Today we have Eduardo Blancas Reyes, who's going to be talking to us about streamlining your data science projects with Plumber. Go ahead and take it away, Eduardo.
Thank you. I'm going to share my screen. Can you see my slides?
Yes, we can see them.
Great. Thanks, Tom. Thanks, everyone, for joining. So today I'm going to be speaking about a project that I've been working on, an open source project for streamlining your data science projects. So what's the deal with Ploomber, the project that I'm going to be talking about? When we are working with data, using Jupyter and having everything in a local environment really helps to understand what's going on, right? So we may encounter a new data set, we may print a few statements, get some summary statistics, create some charts. That really helps to understand what's going on. But then at some point, we may want to run things on a larger scale, say a Kubernetes cluster. I think there are two main cases why we may want to move from a Jupyter environment to a larger environment. One can be we may be running things locally with a sample of the data, and then we want to run the analysis on a larger scale. A second one would be that we may want to run our pipeline, our analysis on a schedule, right? So maybe we are expecting new data to arrive daily, and then we want to process it and then spit out some results. Now, if we go from Jupyter to Kubernetes, we may encounter that we have to make changes to our code, right? We have some notebooks. Maybe if we are using some framework, like Argo workflows or Airflow, we may have to change our code so that we can run it in the cluster. Unfortunately, this is not a one-way street. Pipelines break, analysis break, new data changes. So we have to repeat this cycle. Basically, every time we find an error in our pipeline or we want to improve things, we may want to make things faster or add some new code, some processing code. We have to do this cycle. So the idea with Plumber is to facilitate this whole cycle of having some Jupyter notebook or some function that we are testing locally and quickly run things on the cloud. And then go in the other direction and get the results from our computations in the cloud back to Jupyter so that we can maybe do some more analysis using the results that we got. So Plumber supports three main backends. We can export to Kubernetes using Argo workflows. We can also use AWS Batch or Airflow. So those three. Now, to make things a little bit more concrete, I have this diagram, which is a typical batch machine learning pipeline. And so I'm going to be speaking in terms of this use case of machine learning, but this really applies to any kind of batch pipeline. So we usually start with we get some data, the data that we want to process, then we clean it, we investigate what's going on with the data, we clean it, and then we may generate some features for the model. So we generate a bunch of features, then we may join this in a single file, and then we may train some models. So we train some models, and then we analyze results. So like typical batch processing pipeline. Now, what happens if we use Ploomber? Ploomber allows you to come up with this pipeline easily. So allowing you to get some functions, some scripts, or some notebooks, and build a pipeline without having to write extra code or without having to configure any extra pieces. So just to give you an example of how this may work, let's say that you have this machine learning pipeline and then you run everything, so like from start to finish. And now you're going to start working on a new change. And this is a typical scenario when we are working on some data analysis pipeline. We make a change. We usually make changes that only affect parts of the pipeline, not every piece of the pipeline. So what you may do is you may say, well, I want to improve this part, this feature that I'm working on. I want to modify it using Jupyter. So I have a code change, and then what I can do is I can submit the steps that take the most time, which can be training all these models. So I train that in the cloud and then get back the results and then keep going, keep doing the analysis locally. So Ploomber allows you to go between your local environment and Kubernetes, get the results, and also do these things quickly since it keeps tracks of your source code changes. So in this case, if we are modifying only this part, the only tasks that really have to be re-executed again are the ones that happen after, right? So we don't have to get raw data, we don't have to clean it, we don't have to generate all the other features. So this helps you quickly experiment with your data and see how small changes affect your final result. So that's like the explanation that I want to provide. And then here comes the exciting part, which is the demo. So the most important thing in Ploomber is your pipeline YAML file. And this is the only thing that you have to configure in order to create a pipeline. So I'm going to skip some of the details because we have limited time. So I'm just going to focus on the most important parts. So we have this task section where we are going to create a pipeline. And we have to list the tasks that we want to compute. So to make this easier to explain, I have this diagram that I created using Ploomber plot. So if you create a pipeline, you can execute this command, and then it generates the chart. So we see that we have a bunch of nodes in this pipeline. And this is a really simple machine learning pipeline that gets some data. Then it generates some features, just like the diagram that I showed before, joins the features, then trains a few models, and then compares the models to choose the best one. So that's the idea. Now, how do we create this pipeline? We simply have to enter two pieces of information. The first one is, where's the source code that we want to run? In this case, we are saying go to the tasks module, then raw, then get. So if we open that file, we're going to see that we have a function here. The same logic applies with all the other three functions. These are regular functions. They don't have anything in particular. Now, the only condition for Plumber to recognize these functions is to follow a convention. So these functions need to have a product argument, which we pass from the YAML file, and we specify where we want to save the output from that task. And if we have some dependencies, for example, when we generate features, we want to use the raw data, right, to generate those features. So if we depend on another task, like this task, Sepal, what we do is we add another argument called upstream, and then we just make a reference to another task. In this case, we are saying when we run this task, we want to use get as input. So we add an argument, and then we make a reference to the previous task. And that's it. The rest of the logic is the same: function, product, upstream, a function with product and upstream. Now, if we take a look at the script that we have for training a model, it changes a little bit. We don't have a function anymore. We have a script. And if we take a look at the product argument, which is the one that, where we specify the outputs, we see that it's generating a Jupyter notebook. So this might be surprising. Why is this script generating a Jupyter notebook? The reason is that Plumber executes scripts as notebooks. So if we, for example, in this case that we are training a model, one important thing that we want to do is to get some charts to understand the performance of the model, or we may print the distribution of some variables. So if we take the script, turn it into a notebook, and then execute it, we are going to be able to have a standalone report that we can review. So that's the idea. The other two outputs are simply the pickle file for the model and then some predictions. Now, here comes a new thing. We are parameterizing the script. This is something that happens commonly. We want to run the same task with the same script with different parameters. So in this case, I'm simply saying use the script that trains a model and then simply pass these parameters because I want to train a random forest, a boost, and logistic regression. And then finally, same thing, another script that is going to take the output from here and then generate some charts. Now, if we were working with some small data sets, we could run this locally and it would work great. Plumber is also designed to work 100% locally. But then imagine that we are working with some larger data sets and we want to run this in the cloud. So I already pre-configured this project. It's really simple to do that. We just have to configure some cloud storage. In this case, I'm going to be running this in AWS Batch and storing things in S3. But we could also store things in Google Cloud, run things in Kubernetes. So I'm going to show how I'm going to run this pipeline in the cloud. So I just have to execute this command. So I'm saying export train. Train because that's the name of my target environment. So you may have different target environments, maybe for training, for serving, or some other things that you want to do with your pipeline. So then we press enter. And then we start with the process of taking our code. So it's going to take our code, put it into a Docker image. Then it's going to push that image to a registry, and it's going to start running things. So this is running. It's taking too much to run. So let me see if I can run this here. That's the problem with live demos. So in any case, I have a recorded thing, but let's try again. Let's see if it works. Source. Oh, it's working. Actually, yeah. So I know what happened. I ran this before. So Ploomber is saying I don't have anything to run because you run this already. So what I'm going to do is I'm going to change the configuration to use another bucket that doesn't have anything. So it shouldn't complain and simply run the whole thing. All right. Let's wait for a few seconds. And now it's taking the code and it's going to create a Docker image. So we can see it's creating the Docker image. It's really fast because I already had a previous version. So it's only putting the new code and then updating the image. Now it's running a few tests in case that we didn't configure the pipeline properly. So it's going to complain before we push. So we don't push something that's broken. So now it's testing, running some tests in the image. Wait for a few seconds for this to finish. Right, I'll just get the video in case this takes too long. All right, so looks like it's working. Now it's gonna test the connection with the S3 bucket in case we didn't configure S3. All right, so now it's pushing the image. It's not gonna take long because we already have a previous version, so it's only gonna push the differences. And now we finally see that we are pushing every task, right? So every node in this chart is becoming a task in AWS batch. So I can go to the console and see. I have, all right, here. So I have these pending tasks, which are the ones that I just submitted. We don't want to wait for AWS batch to finish, so I'll change the bucket to something that has, to one that has the outputs already. So that's how you run things in AWS batch or Kubernetes or Airflow. Just simply submit with a command, creates the image, pushes, and that's it. Now, let's assume we already finished running things in the cloud and we want to analyze our results. Right? What we can do is that we can say Plumber build. And then let's say we want to compare the models that we just trained. So I'm going to say partially because I don't want to download everything. I just care about the output from the fit tasks, the ones that train models. And then I'm going to say skip upstream, basically saying just run those things. Don't bother about upstream dependencies. Now, if we didn't have S3 configured, this would run things locally. Since we already ran this in the cloud, Plumber knows that it's better to just download things instead of running everything again. So now it's gonna download the output for each of these fit tasks, which is the Jupyter notebook, the model, and the CSV file. So if I go here, I'll see in a few seconds that I'll have the models and the data that I need. Right, so it's getting the Jupyter notebooks. So I'm gonna open one of these. So we have this is the output. This is the output, so we see some metrics, some chart. This was executed in the cloud. So now I already have the input that I need to work locally. So what I'm going to do is I'll go to my script that analyzes the results from the models, and I'm going to do open notebook. So now, not this one, this one. So now I'll wait for the kernel to start. And since I already have this output, I can start working locally. So I can load the predictions from my models and then generate a few charts. And then say I want to improve my task that analyzes the results, and maybe I do some hello from the cloud and save it. Now I want to run this in the cloud again. So I'll just have to run things. This is probably going to take a few seconds, but the idea is that since I only change this task, Plumber is going to reuse the outputs from the previous tasks and simply going to run this. So having these incremental builds allows us to quickly run things. We don't having to keep track of dependencies and ensuring that our results are consistent. So let's not wait for this to finish. So what's going to happen is simply that's going to schedule this task. So that's it. I want to share some resources. So if you want to give it a try, all the code is open source. So here's the repo. If you like the project, show your support with a star on GitHub. And if you have questions, if you want to use Plumber, feel free to reach out. Here's my Twitter handle and also my email. So that's it for me. So I think we can get some questions.
Great, thanks.